All right, we should be live shortly. There's 5 of you here. Good morning. Just gonna go get my coffee. Now there's 3. I don't know. So when I stream this, I'm looking at YouTube Live Studio. So this is what goes on behind the scenes, and people jump in and out. So for those that are there, welcome. We'll start in a few minutes. Hope everyone's having a great day. Tuesday, Taco Tuesday. There's 5 of you here. Good morning. Good morning. Oh, we have to test the whiteboard. Let's see. So if you're out there in the world, we're going to test the tacos. Oh my God. So yeah, you can clearly see or hear what's on my mind. What is it? Not even 9 a.m. and I'm thinking about tacos. I mean, who doesn't love tacos? I guess there's a lot of people out there that don't like tacos. If you don't like tacos, please leave. Thank you. All right, so I'm going to write on this whiteboard, and let's see if you see what I just wrote. All right, so the whiteboard is live. I just want to make sure that you can see it, and if you do, please chime in. Are you out there? If you are, please say something in the chat. Greatly appreciated. And the birds are, hey, good morning, Liana. And I mentioned birds because I think I told you I was going to get a bird bath, and I have the bird bath set up. They're in there. Ah, this is great. So I was trying to take a picture right now of a bird in the bird bath, and I missed out. But anyway, rest assured that the bird bath is fully functional. Welcome. Let's see. Fish tacos. Who doesn't love fish tacos? Fish tacos don't sound amusing? I guess. So sorry, I just got up for 1 second because I saw birds, dancing around in my bird bath. I know, really exciting stuff. You laugh now. Maybe one day you'll find that stuff enjoyable, entertaining, exciting. Good morning, Elizabeth. Good morning, Kyle. Good morning, Valentina. Good morning, Parthana. Good morning, Sarah. And good morning, Liana. All right. So I have the homework solutions projected there. So if you want, please take a picture of them. Take a moment to review it with your work. I have been looking at your homework, so I don't want you to think that I have not been. So it operates differently within Google Classroom. So I gave you guys grades, but it doesn't automatically publish until I hit send or grade, or there's some button within Google Classroom that I have to hit, so then you get notified that it's been graded. Good morning, Josh. Welcome. All right. So about 1 more minute, we'll let the classroom fill in. Hope everyone's doing well out there. Hope your other classes are going well. I know that we only talk about this one, but you're still attending school, and I hope everything's going well at Academy. So I guess I can tell you now, I can break the news. So this will be the last class that I teach at Academy. As of next year, I will no longer be the College Now instructor. at Academy. I have essentially resigned after this semester, so my time with Academy or my ties end with this class. It's kind of sad, actually. I do love the school. It's been my home for 11 years, and yeah, I think on Friday I resigned, effective the end of the semester. So this will be my last class with Academy. Sad. But, you know, it was a good run. And next year, if everything goes according to plan, I believe that you'll be in good hands, whoever takes over the program. I don't want to reveal names just yet, but I think everyone will be okay. Okay, so let's move forward. Alrighty, so I hope you didn't find the homework too difficult. So we went over essentially simple interest, compound interest, and various numbers of times that we're compounding, whether it's daily, weekly, monthly, quarterly, semi-annually, annually, and who can forget, continuously. And there's different formulas for that. So in the event or when we do have an assessment, I will most likely give you access to those formulas. But then again, if you have a take-home assessment, you'll probably have access to resources. So, I mean, when that day comes, I think the assessment will be less or significantly less stressful than what you've had in the past. So there are some positives here, and they're certainly in your favor. All right, so let's continue. So what are we looking at today? So today we're looking at logarithms. Ooh, I have to charge my computer. See, normally if we were in a classroom, someone would tell me that my battery's running low. Now I have to be accountable for that. So, all right, logarithms. So I know, again, with every section within a particular chapter, I try to find some type of meme or just some type of funny picture, and here's one of them. Again, I do not create any of these. The only fault that I have is that I actually physically go out and seek them for your entertainment or to my own detriment because you're laughing at me, but it's all good. Logarithms. I hope you guys have plenty of rhythms. Logarithms. So, continuing. In the previous section, we're looking at exponential functions. So typically something where y is equal to some base a, and a is raised to some power of x. For all positive values of a, where a does not equal to 1. So the horizontal line test, again, we're looking at functions, one-to-one functionality. It shows that exponential functions are one-to-one and thus have inverse functions. So when we're looking at inverses, remember, switching x and y. The question really now becomes this. What happens when we switch x and y within the exponential function? So if we look here, the equation defining the inverse of a function is found by interchanging x and y. So again, when we have y equals a to the x power, and then we perform the inverse, we have x is equal to a raised to the power of y. So the question now is, how do you isolate y? So in doing that, that's essentially what is the logarithm. So here, y is the exponent to which a must be raised in order to obtain x. We call this exponent a logarithm, symbolized by the abbreviation log. So the expression log base a. So that's the whole thing. If you say log a of x, that's kind of wrong here. So we have a base. So kind of like when you have the exponential function, you have a base that's raised to a power. So here we have the expression log base a of x represents a logarithm in this discussion. So the number a is called the base of the logarithm and x is called the argument of the expression. It is read as logarithm with base a of x or logarithm of x with base a. Typically we would say log base a of x. It implies the same thing. So I wouldn't worry too much about the semantics of it. So let me see if there's any chatter. Or any feedback? No, not yet. Very good. We have about 18 of you viewing. And again, welcome if anyone strolled in late. Good morning. And yes, if you were wondering, I have a cup of coffee in my hand and it tastes amazing. So, for all real numbers y and all positive numbers a, oh wait, yeah, we're all looking at the same slide, great. Let's see, let me reread. So for all real numbers y and all positive numbers a and x, where a does not equal 1, we have y equals to log base a of x, but that's essentially x is equal to a raised to the y power. So they mean the same thing. So the expression log base a of x represents the exponent to which the base a must be raised in order to obtain x. So what power of a will give you x? That's essentially the question here. So that's how you should be approaching all of this. So logarithms. So the minute that you see a log, you can translate it as what power, because you don't know the power. All you know is the base and the answer when that base is raised to a power. So that's how this is interpreted. So log base a of x is basically saying what power of a will give you an answer that's x. So if you look to the right, let me see if let's look at the board. So underneath fish tacos, right? So we're looking underneath, and I hope you guys have access to fish tacos tonight. If you never had them, maybe today could be the first day that you're eating them. And I think there's some taco places that are open. So my Astoria peeps on Broadway, I forget the name of the place, but there's of the taco place. But there's this place called Bund, B-U-N-D, and right next door is some taco place that apparently is very good. So if you're out there, and you shouldn't be out, but if you're ordering food, I think they're still delivering. But I'll stand corrected. Anyway, enough taco talk. All right, so basically this. So we have here log base a of x. I'm now writing on our board. So we have this y equals to log base a of x. But when we look at it from the inverse perspective, so a to the y power gives you x. But if we're looking at it from logarithm language, in the language of logarithms, so what power of a gives you x? It's y. So that's how logarithms work. So the bottom is the exponential form, and the top, or below the red line, right? So below this red line that I just drew is the exponential form. Above it is the logarithmic form. But they imply the same thing. So let's look here. So again, this is essentially the discussion or the argument that I was making on the board. It's been simplified here in the notes. So you have the logarithmic form and the exponential form. So ultimately, they'll both produce the same answer, but if we don't have the power, and it's difficult for us to, the power meaning we don't have the exponent. Sorry, we all have the power to solve, I hope, but if we don't know the exponent, then the logarithm will help us with that. So moving on. So we're looking at example 1. So this should all be in, I think, logs day 1 classwork. Let's see. Hold on. Going to your class work section. Let's see. In learning materials, you should be there. Logarithmic function. Let's see the exact title. Right. So you're looking at logarithmic functions. The first problem should be the following. So I'm scrolling down now on the whiteboard, and we should be looking at 1a, and 1a says the following. Log base x of 8 divided by 27 equals to 3. So we're going to interpret that shortly. So that's the question that we're looking at now. So hopefully you have that. Does everyone have access to it? So make sure that you have the correct handout out. Going back to the live stream. Let's see what's up. So, do we have that question in front of us? Just want to make sure that you have those class materials. Can someone out there just confirm that you have access to those class materials? Because I don't want to assume. I just want to make sure that it works, that you're able to open it, and that you're using it. Anyone? Just waiting for one person. So again, you're going to the handout. It's in Chapter 4, Class Materials. Yes, Brittany. Thank you, Sarah. Thank you, Irene. Awesome. Thank you, thank you. Great, great, great. So we need to figure out how to solve this. Or solve for x. So remember, the logarithm. So if we want to translate log base x of 8 divided by 27 equals to 3. And thank you, Kyle, and thank you, Leanna. So, in other words, what power of x, right, gives us 8 divided by 27? And apparently that would be 3. So if we look here, let's continue. So what we're going to do is the following. So we could take this and we could write it in exponential form. So I'm back to the whiteboard. So I'm just going to translate this into exponential form. So what power of x is going to give us 8 divided by 27? That power is going to be 3. So in other words, x cubed will equal to 8 divided by 27. So if we solve for this, which we can in exponential form, it should be pretty simple by taking the cubic root of both sides. And if we do that, we end up with the following. So this will all simplify to, so again, we're just moving down with it. X is going to be equal to the cubic root of 8, which is 2, and divide that by the cubic root of 27, which is 3. So this should be a final answer. So what power of x, right, or log base x of 8 divided by 27 equals to 3? So what's the power of x that will give us that response? Or it's 2/3. So x is, or the power of x is 3, but log base 2/3 of 8 divided by 27 will equal to 3. So in other words, if we write this in now in its full form, it's really this: log with a base of, right, 2/3, right, of 8 divided by 27 equals to 3. So in other words, writing this now in exponential form, so what power of 2/3 gives us 8 divided by 27? 3, or cubed. So 2/3 cubed will equal to 8 divided by 27. And here we could check, and this is essentially what I just did. So in the check, it gives us the same value. So the solution set will be 2/3. Okay, moving along. So now slightly different. So moving down, next example, we have log base 4 of x equals to 5 divided by 2. So let's look here. Just writing, so this is example B, 1B. Let me change the color. So we have 1B. Good. So log base 4 of x equals to 5 halves. So what power of 4 gives us x, right? Apparently 5 divided by 2. So if we rewrite this as an exponential function, so we're basically going to say 4 raised to the power of 5 halves will equal to x. So remember how we rewrite that exponential or that fractional exponent. So we can do this multiple ways, but don't forget the denominator is the root. And then the numerator becomes the power that we raise that to. So rewriting this as a radical. So this will be the square root. I'll write 2, although it's not necessary, it's implied. So the square root, or 2 root 4, all of that raised to the power of 5. So if we do that, we'll end up with the following. And this should be projected on your end right now. So solving, x will be 32. So again, moving down. So here, 32 equals to x. And if we rewrite this in exponential form, we have the following. So it's really log base 4 of 32 will equal to 5 divided by 2. So in other words, what power of 4 gives us 32? It could only be 5 divided by 2. Or when we raise 4 to the power of 5 halves, it gives us 32. So I'm curious, so as you look at that, as you make your notes, the whiteboard, do you need me to keep drawing the arrows so that you follow along, or is it unnecessary? So again, when I'm in the whiteboard, when you're looking at the work that's happening there, do you need me to draw the arrows so this way that you're guided to where I'm going, or you kind of know what to do? I'm curious. Do the arrows help? Or is it like a waste of time and I'm thinking that it's helpful? I need feedback. So again, my question to you. So in this whiteboard world, when I draw these arrows for you to follow along, does that help? I'm able to follow without the arrows. Okay, I'm okay without them. Interesting, okay. It's kind of like obvious, like, is it like one of those duh things? No, you don't need them. Okay. So is it like one of those duh things like, uh, since he's going down, I'm just going to follow along? Because again, like, I don't know what you see. I don't know how this plays out on your end. Like, if when I scroll down, does it scroll down for you? The arrows aren't completely necessary. All right. So when I scroll down, does it scroll down automatically on your end? I'm curious. The arrows are useful but aren't necessary. All right, so it seems like I don't need to do that. So you kind of follow along. I may still do them only out of paranoia, I guess. I don't know. But I'm taking the feedback, and thank you. Alrighty, so moving along. So I'm not going to use any arrows. All right, here we go. So we have now log. So this is example C, log, hold on, log base 49 of cubic root of 7 equals to x. Oh, you have to scroll down. Okay. I guess then that makes it a little more interactive. Now, do you guys save the boards? Do you ever go back to old boards just to make sure that if you need to double check something or if you don't understand a particular step? Are you referring back to old boards? Because I am saving them on my end. And again, I appreciate all the honest feedback. I need it too. Two-way street. All right, so continuing along with this question. So again, when possible, there I go again with the arrow. So when possible, 49. Remember, we're going to, I take notes while you write. Thank you, Liana. That's awesome. So if we look, again, we have to solve for x. Thank you, Sydney. Thank you. I saved them. Nice. Great, great. Yeah, and they'll be there. They're for you. And I'm very happy to hear that. I'm glad that you're finding this useful. So, essentially, log. Oh, what is this? So log base 49 of the cubic root of 7 equals to x. So if we think about this as what power of 49 will give us the cubic root of 7. So 49 then. Thank you, Brittany, for writing everything down. Thank you, Mahmoudal, for also taking notes. So 49 raised to the power of x, right? That's going to give us the cubic root of 7. So now the question is, how do we solve this? Ugh. So this one's a little more challenging. Thank you, Sarah, for writing everything down with the classwork. Very cool. All right. So, more challenging, but it kind of goes back to what we did, I believe, before the interest topic, simple interest, compound interest, etc. So we need to rewrite this so we have the same base. So don't forget how you can rewrite 7, or radical, or the cubic root of 7, excuse me. Don't forget that that's 7 raised to the power of 1/3. So now the question becomes, how do you rewrite 49? So remember, we want the same base. Actually, why don't you take a moment to solve for x? I'm going to leave you time. Solve for x. So right now, I leave you with this. I'm going to give you about 2 minutes. So we know that on the right-hand side, the cubic root of 7, right, was rewritten as 7 to the 1/3 power. You need to solve for x, but I'm asking you now to look at 49 raised to the power of x and see if we can figure out a way to make or to solve for x using our prior knowledge. I'm going to give you 1 minute. I apologize for the noise. Amazon dropped off a package. So that's one of the other things that have changed in my life. So now when Amazon, UPS, or whoever else comes, I'm actually here to receive the package. And I don't have to go to their warehouse or the post office because I'm never home to receive the package. So I guess that's one of the benefits of staying home, right? Although my lower back is suffering like crazy. I hope none of you are having that problem. Sitting down all day, not good. I think we spoke about this the other day. For like within an hour, or for every 45 minutes that you sit, then you should stand for 15 minutes, something like that. And now I'm looking at the chat. I see that Sarah successfully said that x is equal to 1/6. So let's see how that plays out. Remember, 49 is really 7 raised to the power of 2, but all of that is raised to the power of x, so that when you solve this, it's really 7 to the 2x power is equal to 7 to the 1/3 power. So in other words, we have 2x, because remember, same base. So here, same base of 7. So we can essentially set these exponents equal to each other. So Irene agrees with Sarah, x equals 1/6, which is great. or she agrees that sitting down for too long sucks. One or the other. And I agree in both cases. So 2x is equal to 1/3. So in solving, you can divide by 2, but it might be better to multiply by 1/2 in case you were having struggles with how Sarah got 1/6. So if we multiply by 1/2, clearly this is gone here. X then will equal to 1/3 times 1/2, which is just 1/6, and I'll show that to you here as well. Okay, so again, typically I would let you try these questions on your own. Maybe you already did. If you did, great. I'm going to give you the solutions to that now. So please take a picture of it. And again, normally I would, spend some time going over it, take pictures of student work. I mean, if you want to show off your work, you can email me on the side and be like, hey, if you want, you can share this. Like, I really don't mind. Or if you want, you can post it on the class wall. It is your classroom too. And I really liked, I think I mentioned it yesterday, but it was really cool to see the collaboration when you had to pick your groups. That someone posted on the wall, hey, we have an extra spot, who wants to join? And someone did. So that was kind of nice to see. So again, we're not limited to just like this YouTube streaming. You can go into the classroom wall, post something of educational value, right? And yeah, it'll be to the benefit of all. All right, so hopefully you took a screenshot of this, took a picture, whatever it is, and if you went ahead and tried to complete it, hopefully everything here matches. So we're going to look now at the logarithmic functions. So again, because exponential functions and logarithmic functions, they are inverses. So if that's the case, then they're going to have this symmetry. So if we look here, y equals 2 to the x power. If we write the inverse of the logarithmic function of it, it becomes log base 2 of x. So the red we know, exponential function, but the inverse of that, or essentially the reflection over the line y equals x, is what the function will look like. So something to look at here, since the domain of an exponential function is a set of all real numbers, the range of a logarithmic function also will be the set of all real numbers. So kind of again, switching x and y will give this result that we're looking at now. Similarly, or in the same way, both the range of an exponential function and the domain of a logarithmic function are the set of all positive real numbers. Thus, logarithms can be found for positive numbers only. So something important. So logarithms can be found for positive numbers only. So it's asymptotic, in other words. So if we look here, just some facts about the domain and range of a logarithmic function. Don't really want to go too detailed into this. This is in your notes, and again, I'm just paying attention to the time, and I want to take advantage of that. So you can see the asymptotic behavior. The line approaches the y-axis, but it will never intersect. So if you look there, so again, our domain in this case cannot be less than 0. And similarly here, again, this will occur. So if we're looking at this function here, log base a of x, right? So what are we looking at here? So here, this is what happens when your base in the logarithm is between 0 and 1. And again, it's going to be asymptotic about the y-axis. So we cannot have a value in the domain that's less than 0. So again, kind of to summarize. So kind of to summarize some points about the graphs, we spoke about the asymptotic behavior. We looked at the domain, we looked at the range, and there's that little graphic that kind of highlights the asymptotic behavior that's found in these logarithmic functions. Can't touch this. So typically we would graph, but again, in the interest of time, I'd rather focus on some other things. So I'll provide solutions to this, so I wouldn't worry too much. Graphing, again, is just to show you the symmetric behavior that it has. Again, the logarithmic function with its inverse, which would be the exponential function. So again, it's just good to compare. So I'm just kind of going through this quickly, just so you can see what a logarithmic function looks like. And there's some translations and things like that here. Yeah, I would love to spend more time on this, but I'm going to just move on to the next section only because this is kind of tough. So if you look here, so I really skipped an entire section based on graphing, but just note that if you have a graphing calculator, which you will have access to, so if you don't have a TI-84, I wouldn't, or whatever, a TI calculator, I wouldn't be too concerned. I can definitely give you a resource if you haven't found one already that will allow you to plot points. At the very least, you can always use Desmos. Desmos will definitely give you some point values that you can plot so that you can bring these logarithmic functions to life graphically. And again, similarly to the exponential function and the translations, so how the graph moves up and down, or vertical shifts, horizontal shifts, that all applies to this as well. So if you just wanted to take a look, so again, I would take a picture of this just so you can see how these graphs would have looked like. And I think today, I mean, I could go on, but the issue is this, that the next section, there's a lot, and I cannot go over it quickly. So if I start it now, it's kind of in vain or to your detriment. So I think at this point, we're going to end for today. So again, what did we look at? We looked at logarithms, and we quickly looked at the graphs of logarithms. So I think you have more than enough content, more than enough material there to actually do all the homework that's related to this. So do you have any questions for me, especially with the project? Is there anything that you want to ask now related to the project? So we still have a few minutes left. So again, that project is going to be due on Friday. So I've given you about a week to do that. No, actually exactly 1 week. I hope you divided the work evenly. So are there any questions related to the project? Now is the time to ask. So we do the log day 1 homework. So let me just pull that up. Great question, Liana. I'm curious, just so I know, are your other classes, are they doing video conferences now? Are you able to see the teacher? Are you having conversations with your teacher? Am I still kind of like doing this old school where I'm just talking and no one's talking back with their actual voice? I'm curious. Because I know that about almost a month? Yeah, like 3 weeks ago, I was taking a poll, or I was surveying the class, and I really wanted to see what you guys were doing in your other classes. So are you interacting? I say no. So you're not interacting. Got it. No, they just assign work. So am I doing too much work? Do you think I should just assign work and not stream anything? So am I like am I going above and beyond? You know, typically the title of, never mind. That's for another day. But some teachers make videos on the topics and we have to watch them. All right, so that's kind of cool. That's cool that, they'll make videos, not necessarily live, but you see your teacher in the video. I feel like it's good to get your explanation. All right. So while the feedback goes back and forth there, so logs day 1 should be the homework. Let's see. Some of you already turned in. I just want to see the homework and what that is exactly. Oh boy. Just give me 1 second here. I'm still looking. Logarithms, day 1. So, from the day 1, yeah, just the circle questions. Good. So it's fair. Yeah, I don't think I assigned any graphing work. So whatever I circled in logs day 1, that will be the homework. They speak over PowerPoints and explain them. Okay, so I mean, it's kind of hard with math, but I know Ms. Greenspan does videos. That's cool. I like the streaming. It helps me understand. It gets confusing without videos. Okay. So in other words, this is helpful. You feel like you're getting something out of this. So that's what you're trying to tell me, because I just need to make sure that you're learning, that this is beneficial, that it's not just me using technology to be like cool or whatever. I just want to make sure that it is helping you. So any questions related to the project? Because again, on Friday, you are expected to submit this project that has multiple parts. I hope that you divided the work evenly. Some parts of the work are insanely simple, that it will not take that long. There are other parts, though, that are more laborious. So I just want to make sure that when you are in your group, that the work is divided evenly, that there's not one person that's doing all of the work. I know that that happens sometimes, but I just want to make sure that it's fair, that it's equitable to you and to your group. Because remember, you will get 1 grade, so don't forget that. Whatever you turn in, it's very nice that there's 4 names on it. It's great, but whatever that grade is, it goes to the entire group. I just want you to remember that. So, please submit the highest quality work possible, because I want you guys to get the highest grade possible. And I still need to think over the exam. Again, definitely not having any type of assessment this week. I am kind of keeping it, light to some degree. And another thing that I'm going to propose, because we are learning during spring break, there is a chance that this course could end even earlier than the anticipated date. Again, I have to speak to Mr. Randall, but I think the anticipated date that we had, it was going to be June 2nd or June 1st, because that, again, this was in the old world where prom and, all these things and the unofficial senior cut day, whatever that is, was supposed to take place, but everything has changed. So what I'm saying, long and short of it, because we're working this week, there is a slight chance that we may be able to end the course earlier than anticipated. Before we were ending in June, there is a chance that we may be able to end at the end of May. Not 100%. This is only a possibility. I have to talk it over with Randall, but I'm just letting you know now. I wish I could see your faces. I hope that you're smiling ear to ear. Maybe there's a face out there that's saddened that we're ending early. Again, I don't know. Because if it ends early, then that means that our time together is numbered. Even, now the window of time is narrower. So it's kind of bittersweet. But again, I want to do what's best for the class. I want to do what's best for you guys, what's best for the school, etc. So something to think about. and I'll have more details by Friday. In addition, you'll have more exam details. Can we do maybe like a fun project as an exam? Something more uplifting. I don't know. I like that, Valentina. Please, you know what? You have a task, Valentina. I want you to come up with what you think would be fun and uplifting, and we can talk about it. I am down. I am down. Right? So there's a lot of freedom here, a lot of creativity can happen in this new world. I'm completely down. I thought that by, even introducing in this project the idea of, you guys looking into a physician's assistant, and doctors and nurses, that there would be some intrigue there. Because I don't think a lot of people know the role of a physician's assistant and how lucrative of a job that it can be. So that was part of it, but uplifting, I like that. It may not necessarily be the most uplifting thing, but please, Valentina, I don't mind if you brainstorm an idea and share it with me, but I'm okay with that. I'm cool with it. You can message me, send me an email, and we can talk it over, or chat, or go back and forth via email. Down. But for this one, we'll finish this project. It will be due Friday. And for project 2, we can think about some ideas, and we'll make it fun and uplifting. It could be completely decided by the class, as long as it's related to what we're covering in this course. I am down. 100% down. So on that note, you have your homework. That will be due by Friday. You have your project. If you have any questions, please don't hesitate. I'm here. You can chat. And on that note, enjoy the rest of your day. And try to have tacos later. Taco Tuesday. Fish tacos. Don't forget. They're the best. Oh my God, they're so good. All right, enough food talk. Time to continue learning in your other classes. Have a great day, everyone. Bye.